Question 1. From the perspective of an instructor preparing a lesson on HVACR system diagnostics, Mr. Alvarez notices his students frequently confuse root causes with symptoms during troubleshooting exercises. What is the best instructional approach to help students develop deeper diagnostic skills? A. Provide detailed lists of common faults and their symptoms to memorize. B. Use real-world fault scenarios to encourage critical thinking and systematic analysis. C. Focus on teaching component replacement procedures rather than diagnostics. D. Emphasize speed in identifying faults to improve exam performance. Answer. Correct answer. B. Explanation. Using real-world fault scenarios encourages students to think critically, apply diagnostic steps, and differentiate between symptoms and root causes. Essential skills for effective troubleshooting. Simply memorizing fault lists leads to superficial understanding and guessing. Emphasizing replacement over diagnosis prevents skill development needed for troubleshooting. Prioritizing speed over accuracy risks misdiagnosis. Instruction focused on practical, scenario-based learning helps students internalize diagnostic processes consistent with best teaching practices in HVACR. Question 2. Given the circumstances of a newly installed variable refrigerant VRF system, Mrs. Patel needs to train her students on how refrigerant charge affects system performance. Which concept best explains why an incorrect refrigerant charge impacts capacity and efficiency? A. Refrigerant charge does not affect heat transfer efficiency. B. Undercharging reduces evaporator pressure, limiting heat absorption. C. Overcharging increases suction pressure, improving cooling capacity. D. Refrigerant charge only affects compressor oil return, not performance. Answer. Correct answer. C. Explanation. An overcharge raises suction pressure, which increases compressor workload and can cause flooding of the compressor or liquid slugging, reducing capacity and efficiency. Undercharging lowers evaporator pressure, reducing heat absorption and cooling capacity, but overcharging typically causes more damage and inefficiency. Refrigerant charge directly affects heat transfer by controlling pressure levels. Oil return is influenced by charge but is secondary to the primary thermodynamic effects. Understanding charge impact is critical for ERF system optimization. Question 3. When analyzing HVACR safety training, Mr. Nguyen finds some students underestimate the risks associated with handling refrigerants. Which explanation best highlights the importance of proper refrigerant safety procedures? A. Refrigerants are non-toxic and require minimal safety precautions. B. Exposure to refrigerants can cause frostbite, respiratory issues, and environmental harm. C. Refrigerants are only hazardous during system installation, not maintenance. D. Wearing gloves alone is sufficient protection when handling refrigerants. Answer. Correct answer. D. Explanation. While gloves are necessary, relying on them alone is inadequate because refrigerants can cause frostbite, respiratory distress, and contribute to environmental damage. Comprehensive safety includes proper ventilation, use of personal protective equipment, leak detection, and adherence to EPA regulations. Underestimating risks leads to accidents. Refrigerants pose hazards beyond installation. In maintenance and recovery processes also require strict safety protocols. Safety training must cover all aspects to prevent injury and environmental harm. Question 4. As illustrated by the experience of Is Jackson teaching psychrometrics, students struggle to grasp the practical use of the psychrometric chart in HVACR system design. Which teaching method is most effective to improve their understanding? A. Having students memorize all chart lines and values by repetition. B. Presenting hands-on exercises that involve plotting real air conditions and interpreting changes. C. Explaining theoretical concepts without application examples. D. Avoiding the chart and using software tools exclusively. Answer. Correct answer. D. Explanation. Avoiding the psychrometric chart altogether weakens foundational knowledge. It should not be neglected in favor of software alone. Hands-on exercises plotting real data help students link theory with practice, deepening understanding. Memorization without application does not foster comprehension. Pure theory without practical context makes the chart abstract and difficult. Combining traditional chart skills. Software use is best as it prepares students for varied real-world scenarios. Teaching must balance conceptual and applied learning. Question 5. Considering the evidence on adult learning principles, Mr. Lewis wants to enhance retention in his HVACR classes. Which strategy aligns best with adult learning theory? A. Delivering long lectures with dense technical jargon to cover more content. B. Incorporating active learning and relating content to students' prior experiences. C. Focusing exclusively on textbook reading and note-taking. D. Avoiding discussions to keep lessons efficient and on schedule. Answer. Correct answer. C. Explanation. Focusing exclusively on reading and note-taking is passive and reduces engagement. Adult learners benefit from active learning that connects new information with their background, improving retention and motivation. Long lectures with jargon overwhelm and disengage. Avoiding discussion stifles interaction and deeper understanding. Adult learning theory emphasizes experiential, relevant, and participatory instruction. Meaningful learning, essential in technical fields like HVACR. Question 6. Based on the information about HVACR controls, Mrs. Kim notices that students often confuse open-loop and closed-loop control systems. Which of the following best distinguishes a closed-loop control system in HVACR? A. It operates without feedback, relying on preset settings only. B. It continuously adjusts output based on feedback from sensors. C. It manually controls equipment without automation. D. It uses mechanical switches without electronic sensors. Answer. Correct answer. C. Explanation. A closed-loop system continuously monitors output and adjusts inputs using sensor feedback to maintain desired conditions, ensuring precise control. Open-loop systems lack feedback and cannot self-correct. Manual control lacks automation and is not closed-loop. Mechanical switches may be part of control but do not define closed-loop. Understanding feedback mechanisms is essential for instructing HVACR controls, enabling students to design and troubleshoot systems effectively. Question 7. When faced with teaching the environmental impact of refrigerants, Mr. Thompson aims to clarify why some refrigerants have been phased out. What concept best explains this regulatory trend? A. Refrigerants are replaced primarily for cost reasons. B. High global warming potential and ozone depletion drive regulation changes. C. Older refrigerants are less efficient but have no environmental impact. D. Regulations are solely motivated by manufacturer preferences. Answer. Correct answer. D. Explanation. Regulations primarily target refrigerants with high ozone depletion potential and global warming potential to mitigate environmental harm, not cost or manufacturer preferences. Many older refrigerants like EFCS, HFCS were phased out because they damage the ozone layer and contribute to climate change. Efficiency concerns are secondary. Manufacturer preferences do not. Regulation, international agreements e.g. Montreal Protocol and environmental science do. Teaching must connect environmental impacts with regulatory frameworks. Question 8. Through the lens of HVACR installation procedures, Mrs. Chen observes students often neglect system airflow testing after installation. What is the critical consequence of omitting proper airflow measurement? A. The system will automatically adjust airflow to optimal levels. B. Incorrect airflow can lead to decreased efficiency, equipment damage, and occupant discomfort. C. Airflow measurement is only necessary for large commercial systems. D. Airflow does not affect system performance if refrigerant charge is correct. Answer. Correct answer. A. Explanation. Systems generally do not self-correct airflow. A proper measurement and balancing ensure correct air volumes. Incorrect airflow reduces heat exchange efficiency, causes premature equipment failure, and creates comfort problems like hot-cold spots. All system sizes require airflow verification. It is not exclusive to large installations. Even with correct refrigerant charge, poor airflow impairs performance. Installation best practices mandate airflow testing to ensure reliable operation and occupant satisfaction. Question 9. With respect to HVACR safety regulations, Mr. Evans needs to stress the importance of lockout-agout procedures during lab management. Which rationale best justifies this emphasis? A. Lockout-agout only prevents theft of equipment. B. It prevents accidental energization of equipment, reducing injury risk during maintenance. C. It is optional if safety glasses are worn. D. Lockout-agout is irrelevant for HVACR systems with low voltage. Answer. Correct answer. D. Explanation. Lockout air prevents unexpected startup or energization, which can cause serious injury or death during maintenance. It is a critical OSHA requirement for all systems regardless of voltage, because hazards exist even in low voltage equipment. It does not prevent theft. Wearing safety glasses does not replace lockout air procedures. Emphasizing these procedures is essential in lab management to protect students and comply with safety standards. Question 10. Taking into account the fundamental principles of heat transfer, Istagasi explains why insulation in ductwork reduces energy loss. Which principle best explains this effect? A. Insulation increases heat conduction, improving system performance. B. Insulation decreases heat transfer by conduction and convection, conserving energy. C. Insulation blocks radiation but has no effect on conduction. D. Insulation is only necessary for refrigeration lines, not ducts. Answer. Correct answer. B. Explanation. Insulation acts as a barrier reducing heat transfer by conduction and convection, minimizing energy loss or gain through duct surfaces. It also somewhat limits radiant heat transfer. Increasing conduction would raise losses, which insulation prevents. Radiation is part of total heat transfer, but not the sole factor insulation addresses. Ducts require insulation, especially in unconditioned spaces, to maintain system efficiency, not just refrigeration lines. This principle is central to energy conservation in HVACR design and instruction. Question 11. Under the assumption that Mr. Roberts is teaching HVACR blueprint reading, he wants students to correctly interpret mechanical symbols for troubleshooting. Which approach best helps students avoid misinterpretation of schematics? A. Encouraging memorization of symbol lists without context. B. Providing hands-on practice by tracing real equipment diagrams and matching components. C. Teaching only electrical symbols since mechanical symbols are rarely used. D. Using generic symbols without teaching their specific meaning in HVACR. Answer. Correct answer. C. Explanation. Teaching only electrical symbols is inadequate because HVACR systems rely heavily on mechanical components, and ignoring mechanical symbols limits understanding and troubleshooting skills. Memorization without application is ineffective. Generic symbols without context lead to confusion. Hands-on practice with real diagrams is best to help students interpret schematics that are accurately essential for diagnosing problems and installation planning. Question 12. In light of recent developments in green technology, Williams is instructing about energy-efficient HVACR systems, which feature most directly contributes to reducing a system's environmental footprint. A. Using oversized equipment to ensure capacity under all conditions. B. Implementing variable speed drives on motors to match load requirements. C. Disabling controls to maintain constant output regardless of demand. D. Selecting equipment without regard to refrigerant type. Answer. Correct answer. B. Explanation. Variable speed drives adjust motor speeds to match actual load demand, reducing energy consumption and wear, directly improving efficiency and environmental impact. Oversizing equipment causes short cycling and energy waste. Disabling controls negates efficiency gains. Refrigerant type is important environmentally, but is separate from motor-driven efficiency improvements. Proper control strategies and equipment selection are pillars of green HVACR technology education. Question 13. By evaluating a scenario where Mr. Singh is instructing on HVACR system maintenance, students question why routine filter changes matter. Which explanation best justifies the importance of regular air filter maintenance? A. Filters only affect indoor air quality, not system performance. B. Dirty filters increase system airflow, improving cooling capacity. C. Clogged filters restrict airflow, reduce efficiency, and strain components. D. Maintenance is only necessary when filters appear visibly dirty. Answer. Correct answer. D. Explanation. Maintenance should be scheduled regularly regardless of visible dirt, because filters can accumulate particles not easily seen, leading to airflow restriction, decreased heat exchange efficiency, increased energy use, and potential damage to fans and coils. Filters directly affect both indoor air quality and system performance. Dirty filters reduce, not increase airflow. Waiting for visible dirt is reactive and can lead to costly issues. Routine maintenance is a proactive best practice. Question 14. Among the various methods for HVACR airflow measurement, Mrs. Davis is demonstrating balancing techniques. Which instrument provides the most accurate measurement of airflow velocity in ductwork? A. Thermometer. B. Anemometer. C. Manometer. D. Pressure gauge. Answer. Correct answer. A. Explanation. The thermometer measures temperature, not airflow velocity. An anemometer is designed specifically to measure air velocity, making it the most accurate instrument for airflow measurement. A manometer measures pressure differences but cannot directly measure airflow velocity. Pressure gauges measure static pressure, useful in diagnostics but not velocity. Accurate airflow measurement is critical for balancing HVACR systems and ensuring proper operation. Question 15. From a practical standpoint, Mr. Hernandez notices students struggle with understanding the impact of duct leakage on system performance. Which outcome best describes the effects of significant duct leakage? A. Increased system efficiency due to outside air mixing. B. Reduced equipment lifespan and increased energy costs. C. Improved occupant comfort by adding fresh air. D. No effect if the refrigerant charge is correct. Answer. Correct answer. A. Explanation. Duct leakage typically causes loss of conditioned air, reducing system efficiency and increasing energy consumption, leading to premature equipment wear and occupant discomfort due to temperature inconsistencies. It does not increase efficiency or comfort. Outside air infiltration often adds unconditioned air, increasing load and reducing performance. Proper duct sealing is vital for system efficiency, regardless of refrigerant charge. Understanding leakage impacts is essential for design and maintenance. Question 16. When considering HVACR thermodynamics, Lee wants students to grasp the relationship between pressure and temperature and refrigerants. Which statement best reflects this relationship? A. Pressure and temperature and refrigerants are unrelated. B. Increasing pressure raises refrigerant temperature following saturation principles. C. Lowering pressure increases refrigerant temperature. D. Refrigerant temperature remains constant regardless of pressure changes. Answer. Correct answer. D. Explanation. Pressure and temperature of refrigerants are directly related through saturation properties. Increasing pressure raises saturation temperature, and lowering pressure decreases it. The statement that temperature remains constant regardless of pressure is false and contradicts thermodynamic principles. Understanding saturation curves is fundamental in diagnosing system operation. Correct interpretation of these relationships helps technicians maintain system efficiency and performance. Question 17. Taking into account building science concepts, Mr. Murphy teaches that the building envelope impacts HVACR load calculations. Which factor most influences heating and cooling loads related to the envelope? A. The type and amount of insulation in walls and ceilings. B. The refrigerant type used in the HVACR system. C. The brand of HVACR equipment installed. D. The electrical wiring method in the building. Answer. Correct answer. B. Explanation. Refrigerant type does not affect the building envelope's thermal performance or heat gain losses. The envelope's insulation controls heat transfer through conduction, influencing heat and cooling loads. Equipment brand and wiring methods are unrelated to envelope heat transfer. Accurate load calculations depend on assessing insulation levels, air leakage, window types, and orientation to size equipment correctly. Essential knowledge for HVACR instructors. Question 18. In terms of HVACR codes and standards, ISIS new and explains to students why adherence to local electrical codes is critical during installation, which is the primary reason for strict code compliance. A. To reduce installation costs regardless of safety. B. To ensure safe operation and reduce electrical hazards. C. To avoid warranty claims from manufacturers. D. To simplify the installation process. Answer. Correct answer. C. Explanation. Code compliance primarily ensures safety by preventing electrical hazards such as shocks, fires, and equipment damage. Reducing costs or simplifying installation should never override safety concerns. Avoiding warranty claims is secondary. Safety is the overriding principle. Electrical codes protect occupants, workers, and property. Teaching the importance of safety through code compliance prepares students for responsible professional practice. Question 19. While examining HVACR refrigeration cycles, Mr. Allen wants to emphasize the role of the expansion device. Which function best describes the expansion device's role? A. Compressing refrigerant to raise pressure. B. Removing heat from refrigerant. C. Metering refrigerant flow and lowering pressure before the evaporator. D. Circulating refrigerant through the condenser. Answer. Correct answer A. Explanation. The expansion device meters refrigerant flow and reduces its pressure, allowing it to evaporate and absorb heat in the evaporator. Compressing refrigerant is the compressor's role. Heat removal occurs in the condenser. Circulation through the condenser is driven by the compressor and system design. Understanding the expansion device's role is fundamental to grasping refrigeration cycle operation and troubleshooting. Question 20. Given the circumstances of a hands-on lab, Carter is instructing on brazing copper piping. Which practice is most critical to ensure a strong, leak-free joint? A. Using excessive flux to cover all pipe surfaces. B. Preheating the joint evenly before applying filler metal. C. Applying filler metal before heating the joint. D. Cooling the joint immediately with water to harden it quickly. Answer. Correct answer B. Explanation. Even preheating ensures proper flow and adhesion of filler metal, producing a strong, leak-free joint. Excessive flux can cause contamination and corrosion. Applying filler metal before heating results in poor bonding. Cooling joints too quickly with water weakens the joint and may cause cracks. Proper brazing technique is essential for durable HVACR piping installations, preventing leaks and ensuring safety. Question 21. Given the circumstances, Mr. Davis is training students on troubleshooting advanced HVACR systems. His students often overlook sensor calibration. Why is sensor calibration critical in modern control systems? A. Incorrect calibration causes false readings, leading to improper system responses. B. Sensors do not require calibration once installed. C. Calibration only affects system aesthetics, not performance. D. Sensors are self-calibrating and need no human intervention. Answer. Correct answer C. Explanation. Sensor calibration ensures accurate data input to control systems. If false readings due to poor calibration lead to improper cycling, inefficient operation, and increased wear. Sensors are not self-calibrating and require periodic verification. Calibration impacts system performance directly, not just aesthetics. Proper calibration is fundamental for reliable automated control, energy efficiency, and comfort in advanced HVACR systems. Question 22. To illustrate this point, Ford teaches about psychrometrics in humid climates. Which parameter on the psychrometric chart best indicates the moisture content in the A. Dry bulb temperature. B. Relative humidity. C. Enthalpy. D. Specific humidity ratio. Answer. Correct answer D. Explanation. Specific humidity ratio quantifies the actual amount of moisture per unit of dry air, making it the definitive measure of moisture content. Dry bulb temperature measures air temperature only. Relative humidity is a ratio relative to saturation but doesn't quantify absolute moisture content. Enthalpy represents total heat content, sensible plus latent, not moisture specifically. Understanding these distinctions helps in designing and controlling HVACR systems in humid environments. Question 23. In the modern context of HVACR safety, Mr. Clark wants to emphasize electrical hazard mitigation, which practice most effectively reduces shock risk during equipment service. A. Using insulated tools and following lockout-out procedures. B. Wearing cotton gloves for insulation. C. Only turning off the thermostat before servicing. D. Assuming low voltage components are safe to handle live. Answer. Correct answer B. Explanation. Using insulated tools combined with strict lockout-out ensures electrical circuits are de-energized, greatly reducing shock risks. Cotton gloves offer minimal electrical protection and are inadequate. Turning off only the thermostat does not cut power at the equipment. Assuming low voltage components are safe is dangerous. Electrical safety protocols protect technicians and are critical elements of HVACR training. Question 24. With respect to building automation systems, Basis Ramirez is teaching about integration with HVAC equipment, which capability distinguishes BAS from standalone HVAC controls. A. BAS can only control heating systems. B. BAS provides centralized monitoring and control of multiple building systems. C. BAS functions only during system commissioning. D. BAS replaces the need for HVAC thermostats entirely. Answer. Correct answer. A. Explanation. BAS provides centralized monitoring and control of HVAC, lighting, security, and other systems, enabling energy optimization and facility management. It controls more than just heating. BAS operates continuously, not only during commissioning. It works alongside thermostats, not replacing them. The integrated control improves efficiency, comfort, and operational oversight. Key concepts for Instructors teaching modern system design. Question 25. When evaluating the merits of different refrigerants, Mr. Kim explains the significance of ozone depletion potential, or which refrigerant characteristic contributes most directly to A. High global warming potential. B. Presence of chlorine atoms in the molecular structure. C. Low boiling point. D. Toxicity level. Answer. Correct answer. B. Explanation. Chlorine atoms in refrigerants like EFCS catalyze ozone destruction in the stratosphere, directly contributing to high global warming potential. Relates to climate impact, but not ozone depletion. Boiling point and toxicity do not influence ozone layer effects. Differentiating OPWs are fundamental to understanding refrigerant environmental regulations. Selecting alternatives. Question 26. Across different scenarios, Istipati's teaching airflow measurement techniques. What is the primary reason for using a manometer during duct testing? A. To measure airflow velocity directly. B. To detect pressure differences indicating leaks or restrictions. C. To measure ambient temperature changes. D. To assess refrigerant charge levels. Answer. Correct answer. D. Explanation. Manometers measure pressure differences, which help identify duct leaks or blockages indirectly by detecting changes in static or differential pressure. They do not measure airflow velocity directly. That's the function of an anemometer. Ambient temperature and refrigerant charge are unrelated to manometer usage in duct testing. Understanding pressure measurement is key in diagnosing airflow problems and ensuring balanced HVACR performance. Question 27. When faced with curriculum development challenges, Stewart considers adult learning principles. Which design element best supports learner engagement and retention? A. Incorporating real-world examples and hands-on activities. B. Using exclusively lecture-based delivery. C. Assigning dense reading material without practical exercises. D. Minimizing student interaction to keep the class quiet. Answer. Correct answer. A. Explanation. Adult learners learn best through practical application and relevance. Real-world examples and hands-on activities improve engagement and retention. Lecture-only formats are passive and less effective. Dense reading without application leads to poor understanding. Minimizing interaction reduces opportunity for feedback and active learning. Effective HVACR instructor curriculum leverages experiential learning and education theories. Question 20. Taking into account system repair best practices, Mr. Johnson advises on compressor replacement. Which precaution is most critical during compressor removal? A. Immediately installing a new compressor without vacuuming the system. B. Recovering refrigerant and evacuating the system to remove moisture and non-condensables. C. Disconnecting electrical wiring without labeling. D. Using the same mounting bolts from the old compressor regardless of condition. Answer. Correct answer. A. Explanation. Proper refrigerant recovery and system evacuation remove moisture and contaminants that can damage the new compressor and degrade system performance. Installing without evacuation risks compressor failure. Labeling wiring is essential for safe, correct reconnection. Using worn mounting bolts can cause vibration issues. Safe and thorough procedures during compressor replacement are vital for reliability and system longevity. Question 29. Throughout the course of teaching HVACR tools, Mrs. Thompson highlights the importance of tool maintenance. What is the primary benefit of regularly calibrating HVACR gauges and meters? A. To ensure accurate measurements for diagnostics and system charging. B. To reduce the need for replacement tools. C. To speed up the measurement process regardless of accuracy. D. To meet manufacturer warranty requirements only. Answer. Correct answer. B. Explanation. Calibration ensures accuracy, which is critical for diagnosing issues and correctly charging systems. Accurate tools prevent costly mistakes and ensure safety, while calibration can extend tool lifespan. The primary benefit is measurement accuracy, not speed or warranty compliance. Proper tool maintenance is foundational for professional HVACR practice and instructional credibility. Question 30. The fundamental question is, during installation of ductless systems, Mr. Lopez stresses the importance of proper refrigerant line sizing. Which issue arises most commonly from undersized refrigerant lines? A. Excessive refrigerant flow improving system efficiency. B. Increased pressure drop causing reduced system capacity and possible compressor damage. C. Reduced system noise due to smaller pipe diameter. D. No effect on system operation if insulation is adequate. Answer. Correct answer. A. Explanation. Undersized refrigerant lines cause excessive pressure drops, leading to insufficient refrigerant flow, reduced cooling capacity, and increased compressor stress, risking damage. Smaller diameter does not reduce noise, but can increase it due to turbulence. Adequate insulation does not compensate for improper line sizing. Correct line sizing is critical for reliable and efficient ductless system performance.